Hello, I'm going to make a few little rough videos. By that I mean I'm not going to produce these with titles and music, and I'm not writing any scripts, just talking to you about some of the things that we can do in R in order to analyze data. I know that getting started with R can be daunting, and even those of you who have been doing it for a while, some of the commands that we're using for doing this particular assignment might look peculiar to you. So I want to go ahead and do a little series of videos, little short videos, to walk through some of the steps in R a little more slowly than we have time to do in class. If this isn't useful to you, just skip it. There's no requirement that you watch this. So I've started here with the little chart that I provided you in Blackboard, and I also showed you in class, that kind of summarizes what types of things we looked at in EDRM 710. And so we're going to start up here in the upper right-hand corner, a single categorical variable. And to remind you, the graph for that we use as a bar chart. The descriptive statistics are frequencies and proportions, and the inferential statistic is a confidence interval for a proportion. So the variable that we're going to start with is SES. Now, obviously, we first need to get our data into R. And so we have to have a CSV file in order to get that data into R. I'm going to pause this just for a moment and come right back because I noticed the lovely and talented Jennifer is standing outside the office door wanting to come in. So let me pause it and I'll be right back. Okay, I'm back. So we were talking about getting data into R. If you don't yet know how to do this, make sure you watch the Getting Started with R series because it's very important you know how to start a project. I do have a project going right now. You can see my project folder down here in the lower right, review of EDRM 710, and up here in the upper right, you can see that it says that that's the project that I have going right now. So I have a project going, and I have already saved the data in a CSV format. Don't do anything extra to the data. I was helping someone out just the other day trying to figure out where all their error messages were coming from, and what I found out was in their Excel file that they had made things really pretty. They had highlighted the variable names, and they had changed the color background. Well, when they converted to a CSV, a lot of that stuff carried over, and R looked at that and said, I don't know what this is all about, and gave error messages. So we just want just a plain CSV file. If I click on this and say View File, I see that all I have is text with commas separating. All right, so I use the read table, but another one that's commonly used here is read.csv. Either one will work for this kind of file. And so I'm going to run this, and I got a warning message. What's going on here? Oh, I know what it is. Okay, my bad. Let me start this again. It's because I just created something new in my desktop, and it warned me about that, but it only does it one time. So from now on, we're going to be good. Let me try again to run, and sure enough, now this time I have it. If I look in my environment, I see that I have a students file here, 200 observations and 11 variables. I feel good about that. There's no need to save it in an R data file. That's just something that I like to do because I work with big data sets, and the R data file saves it nice and compact and reads real easy. So I now have a new file that I created here, hsb2.rdata. All right, now let's get to the crux of this video, which is about looking at a single categorical variable. If we want to get descriptive statistics, we can get the counts. Now in my report, I had to do SES. In your report, you're going to have to do type of school. So you're only going to have 2 categories, which I think makes it a lot easier. I have 3 categories. So if I run this table command here, this is the function right here where it says table, and then in parentheses, I'm telling it what variable to use. The students is the data set. Students is the data set. That's what we saw in my environment. And then if I want to get to a variable in this, I have to use $sign to get to that variable and then name the variable. And we're doing this one here called SES is the variable that we want. And so this is really the command, table, students, SES. In fact, I'm going to go ahead and copy and paste that command over into R, which is up here in my upper right pane. And what you'll see is that it creates my counts. It tells me 47 low SES, 95 middle, 58 high. If you want to see what that 1, 2, and 3 means, go and look at my code book. But what I'm doing here instead of printing it out is I'm saving it in SES counts because we're going to need it in the next line. But I have here my first descriptive statistics for a categorical variable, and that is the count of each SES. So let me go ahead and run line 12 here and save this in ses.counts. For you, of course, you'll be saving your counts of your school type, SCHTYP, which is 1 and 2. I think 1 is public school and 2 is private, but you better check the code book and check me on that. Now, when we want to have proportions instead of counts, and I think proportions or percentages, either way you want to do it, proportions instead of counts, we use prop table is the function, but notice what we have to feed it. We have to feed it the table of counts that we already created. That's why I saved those counts up here. So in prop table, if I were to run this over in the console window, you'd see that it would give me the proportions now rather than the counts. If I want it to get percentages, all I have to do is multiply that by 100 and it gives me percentages. I'm going to save the props as well into this variable called s.props. So line 13, I'm going to run. And I had it highlighted. Let me unhighlight it. There we go. Now, if I type in scs.props, you'll see that we get those proportions. It's saved in there, so to see it, you can either go to your environment window, where we see it, or you can just type out the name of the object or variable that you saved it into. Okay, now I'm going to use those ses.props right down here in the bar plot function. The bar plot function requires me to put in ses.props. All the rest of this stuff is optional, except that it makes our bar plot readable. So for the class, it's not optional. For R, it is our optional. Watch, I'll show you. I'm just going to type in bar plot for those ses not plots, props. And there it is. Okay, but notice no labels. I don't like the range of this axis here very much. So I'm going to change this, and I'm going to add in names for each of these, 1, 2, 3. I'm going to call it low, medium, and high, and I do that with this little argument called names.arg. All the things we feed a function are called arguments. Here I'm going to give it the argument xlab, which will give the X label, ylab, proportion. Ylim will give us that this is going to be from 0 to whatever we put as our top number. I'm going to change it to 0.5 because you see how it's a little bit low right here, so I want it a little bit higher. And then main will give us a main title. So if I click on this, now I have a bar graph with these bars and with this title. Now, if you're actually doing this for a manuscript or even in your reports where you're going to have perhaps a figure heading, you might want to eliminate that title. because you're going to put that title right in your document when you do your figure heading. So if I take out that one line, I get the exact same thing without the title. So that's up to you. It's optional whether or not you put in the title, depending upon how you're going to incorporate it into the report. It really doesn't make a lot of sense to say figure 1 and tell what the title is and then have the title again in the figure. So a lot of times you might want to do this without those titles. So whether or not you have that is going to be optional. All right. So now we've got the descriptive statistics, the count and the proportion. What I'm doing in this next command here is I'm showing them side by side. The cbind function means put these in columns and show this to me in columns. And so I'm going to bind these in columns. That's what cbind stands for. And so when I run that, what it will do is it'll give me the counts that I put in here first and props it will give me next. So I can see lower of my 200 students, 47 are low SES, and that's 0.235 or 23.5%. In fact, watch this. I can even do this. I can say, let's do SES.percents, which is just going to be 100 times SES.proportions. And then I'm going to add to this cbind SES.percents, and now I'll get everything. I'll get counts, proportions, percents. So I'm not saying that that's necessary. Proportions, percents, it's kind of redundant, but I'm helping you learn a little bit about how R works and what you can do. Now, down here, we're going to do confidence intervals for these groups. So what I need to have for a confidence interval is this prop test. And really, I could do this kind of by hand because all I have to do for the confidence interval for low SES is put in prop test, say there's 47 out of the 200 students. Okay, remember our file is a total of 200. That's all I need to do, and it gives me the proportion of low SES in the nation is between 0.18 and 0.30. So you might wonder, why did you do it this way? Well, I did it this way to make it more generic in case the numbers ever change and I read in different data in the future. But let me explain each of these lines. This one is just going to sum up the 3 SES.counts. So that's basically giving me that 200 that I put in. If I put in SES total, that's 200. So I put in prop test, let me scroll back to here. I put in prop test 47 and 200. So I could have just used SES total, or I could put in 200, either way, right here. See it? So this is the second part of the prop test. SES.counts, remember there were 3 of them. Here they are again. There's that 47. It's in the first spot. So if I put SES.counts 1 in brackets, it will just give me that 47. And so by running this prop test here, I get the exact same thing I did before. The next one would be medium SES. The next one would be high SES. Now, when you're doing school type, you really only need to do one school type because if you know one, you do the other. Although for completeness, I'd probably go ahead and do both. But you'll see that one is just the converse of the other one. So that's it. If I go back here to look at single categorical, we did a bar chart. We did frequencies, proportions, and a confidence interval for a proportion. Okay, so that will be, sorry about that. That will be our first variable we'll look at, and then I'll make more videos for the other ones.